Alright guys, here we go. We're taking a look at the special right triangles review. It's actually just all triangles, it's not just special right. So we'll get started here. Number one, the key really to a lot of this is just, first of all, understanding which formula or method you should be using. So take a look at number one, find n. Okay, n's the hypotenuse obviously right here. And you got to be looking at it, what information do I have available to me? The key thing is this 60 degrees right there means that this angle over here has to be 30. So 30, 60, 90, this is going to be a special right triangle. Okay, before we go any further, write your formula out, right? You got 2x on the short side, on the short side, 2x at the hypotenuse, and x square root of 3 on the long side, or the side we normally label b. Now again, the key to this is which side has an actual length. Here it's a 10 square root of 3. So you take the formula for that side, x square root of 3. You set it equal to 10 square root of 3. Now, some of you can see the obvious, hopefully, that this is the same here, except there's a number there, there's an x there, so x should equal 10. But even if you don't realize that, you divide by the square root of 3, cancel, cancel there, cancel, cancel there, x equals 10. Now, we're looking for the hypotenuse side. Now that we know x is 10, the formula says 2 times 10, and 2 times 10 is 20. All right. Number two, find the length of the diagonal of a square whose side length is 9. So, draw a picture, diagonal, that's a right angle, that side matches that side. The diagonal works as a angle bisector, so you're going to get 45, 45, 90. So you do technically have two choices here, and this is kind of up to you. It's a Pythagorean theorem problem if you want, because you do have two sides and you're only missing one. Remember, we're all pretty much always looking for side lengths here. If you have two of them and you're only missing one, Pythagorean theorem is always an option. It's also special right, which, if you know how to utilize it, makes it a little bit simpler. Okay, so we'll kind of talk about both of them. See, with those special right triangles, with 9 being the length on 2 of the legs, and that being x, the hypotenuse is simply x times the square root of 2. So C should be simply plug that 9 in front of the square root of 2, which you don't even, have to write it like that. It's just 9 square root of 2. So that should be the easiest way. But if you don't know that way, or you still get confused by the special right, Pythagorean theorem is still an option. You're just going to have to work it through. 81 plus 81. Sorry, this pen's kind of messing up on the screen. And then you add that together, you get 162, and you got a square root. So the only thing you're going to have to figure out is what would you break this into? What would you factor it? And in fact, anytime you have the same number squared added together, it's going to be the square value, in this case 81, times 2 under the square root. And then running out of space here, square root of 81 is 9, square root of 2 in the back. So either way, that should be your answer. Okay. So the two choices on that, whatever your best understanding. 3, a 24-foot ladder is leaning against a building. The foot of the ladder makes a 60-degree angle with the ground. How far is the ladder from the base of the building? So building, ladder, ground. It says it makes the foot of the ladder makes a 60-degree angle with the ground. Okay, that's vertical and horizontal, so it's perpendicular right there. And it's 24 feet. How far is the ladder from the base of the building? So, make sure you read the question carefully to know what side we're looking for. We're looking for that. This is going to be 30. So be careful on your drawing here, because my drawing's a little bit off. It looks isosceles, but given the numbers and the special right nature, that should be x 2x, x square root of 3. So luckily this one's pretty simple given the information. The hypotenuse 2x equals 24. If you divide by 2, the short leg x is equal to 12. And given our information, that's the side we are looking for. So it's 12 feet from the building to the base of the ladder. For the length of the hypotenuse of an isosceles right triangle is 10 inches, what is the length of one of the legs? So isosceles right triangle, hypotenuse is 10. Again, that's x square root of 2. Some of you figured out this pattern already, but I'll walk through the full steps and then I'll mention the pattern here at the end for it. So we're going to set the x times the square root of 2 equals to 10. Divide by the square root of 2. Cancel, cancel. And x equals 10 divided by the square root of 2, which we cannot keep it like that. So we have to change the value because you cannot have a square root in the bottom. So we're going to do square root of 2 over square root of 2 equals 10 square root of 2 over square root of 4. Remember, square roots being multiplied, you can combine them under one square root, and that gives you 4, which the square root of 4 is 2. Now that you square root it to a whole number, the radicals are out of the denominator. Then you can do 10 divided by 2, which is 5, and that rounds out to your answer. A lot of you realize the pattern in the 45, 45, 90. If you get a whole number on the hypotenuse, that leaves the answer to be half of that number times the square root of 2. So half of 10 was 5, square root of 2. But if not, just follow that process and you'll get to your answer. 5, find the altitude of an equilateral triangle whose sides are 8 centimeters. So all sides the same. Altitude goes straight down. That's 60 because all angles are 60. That becomes 30. This shares into 4 and 4. Again, Pythagorean theorem is an option. You have two sides now of the right triangle because we're only looking at here, 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 and you have the 8 and 4. We're looking for the altitude. It is easier with the special right because the formula gives you x, 2x, x square root of 3. Right here it tells you that x is 4, so for the hypotenuse of x square root of 3, you're just going to plug the 4 in front of the square root of 3, and there's the height. If you didn't do it that way, you would have to do something like 4 squared plus b squared equals 8 squared and solve that, and then simplify the radical. You should wind up with 4 squared of 3. Okay, so again, a couple options. It's up to you as long as you're showing work on what you do. All right, number 6. A kite string is 150 feet long. The string, right there, from the kite to the ground. Yeah, so be careful on that. From the kite to the ground, meaning the horizontal, I'm sorry, not the horizontal, the kind of diagonal down the string itself. So it's 45 degrees at the ground and the string. About how high off the ground is it? So here's our right triangle. That's 45, 45, 90. This gives us x squared to 2 and xx. So again, we have a whole number at the hypotenuse. So again, that's going to cause us to get an answer we're going to have to change once we go through the process, or if you understand the pattern, you can get the pattern in. So you divide by the square root of 2 first. Cannot leave the answer in that form. So you're going to multiply by square root of 2 over square root of 2. That gives you 150 square root of 2 over square root of 4. Square root of 4 is 2. 150 divided by 2 is 75. Square root of 2. Not that bad once you get used to the formula and how it works out. A 24-foot ladder rests against the side of a house. So again, we have a similar situation to what we had on a previous problem. A 24-foot ladder. The base of the ladder is 6 feet away. So the base of the ladder at the bottom, 6 feet away. Approximately how high off the ground is the top of the ladder? Now, first 6 problems all had at least an involvement of special right triangles. Now we get to a situation where there's no measurement of angles. Reread that problem. There is no mention of 45, 45, 60, 30, anything like that. So now this really is just a straightforward Pythagorean theorem problem. All right, so 6 squared plus b squared equals 24 squared. 6 squared is 36. 24 squared is 576. You subtract the 36 over to both sides, and that should be 540. Square root 540, and I don't believe it's a perfect square root. No. So we're going to have to simplify that. Let me move out here just a bit to kind of work with that. Again, we can do factor tree. We can try to find pairs, or you can just start dividing and see if you can figure out dividing it by perfect squares. Divide it by 4, divide it by 9, 16, 25, and see what you can get out of it. I think what 540 is going to wind up being is 4 times the square root of 135. No, actually, I'm going to have to change that, aren't I? Yeah. Okay. 35 could have been broken down, so 135 could have. So actually, it should be 36 times 15. Okay, 36 square roots to 6. Square root of 15 is going to be 5 and 3, which you can't do anything with. So you leave it like that. All right. That one's going to stay there, isn't it? All right, let's finish off this front page. The bottom end of a loading ramp is 15 feet from the side of a loading dock. The length of the ramp is 17. What is the height? So again, pretty straightforward Pythagorean theorem. So 15 squared plus b squared equals 17 squared. 225 plus b squared equals 289, I believe. Minus the 225 to both sides, and you're left with 64. Square root, and the height is 8 feet. All right, page number 1. A lot of special right. Throw in some Pythagorean theorem in the end there. All right, so hope you do well in this one. We're off to page 2.